Hi ladies. So last video we talked about the characteristics of a parabola, which is the U-shaped graph that represents a quadratic function. So today we're going to talk a little bit about graphing, and we're only going to graph parabolas or our functions that are in this form. So just ax squared. So nothing else added onto the end yet. So right now we're just looking at graphs where we have an x squared and a coefficient. And again, that coefficient cannot be equal to 0. Okay, so the vertex of these graphs, when there's nothing else added on, is at the point 0, 0. So that's important to note. When our value for a, that coefficient, when it's a positive number, our parabola is going to open up and our vertex is going to be a minimum point. When our coefficient is a negative number, the parabola will open down and our vertex will be a maximum point. All right, so the first thing that we want to take a look at here is our parent graph. So our parent graph is sort of the most simple form of the parabola, and that's the graph of y equals x squared. So we don't even have a coefficient here. So this graph is shown right here, and it passes through the origin point 0, 0, so that's our vertex, and is only found in these top two quadrants. So the graph, this is the parent function for any parabola that we're going to work with in this chapter. And all other parabolas, based on what we add in front or add on to the end of that function, will result in a transformation of this parent function. Okay, so important to note, right? Y equals x squared passes through the points 1, 1 and negative 1, 1, and has a vertex at the point 0, 0, and it opens up. So let's graph a few examples and see how they compare to this parent function y equals x squared. All right, so the first one we're going to graph is y equals 2x squared. All right, so the first thing that we want to note is that our a is positive, so our parabola will open up. Okay, and we know that our vertex is going to be at the point 0, 0. Wow, that's a pretty bad point there. So let me redo that, and we'll put a little green dot there where our vertex will be. All right, so what we want to do, if you remember doing this in previous chapters, what we're going to do is we're going to make a table of values. Okay, and then we're just going to plot those points. So x and y values. All right, and we're going to go with -2, -1, 0, 1, 2, and see what we get for y values. Then we're going to plot those points. All right, and all we're going to do is plug these x values into this function over here. Okay, so if we take our -2 and plug it in for x, -2 squared gives you +4. +4 times 2 is 8. Okay, if we take our -1, -1 squared is just +1. +1 times 2 is 2. All right, we plug 0 in over here, we're going to get 0. We already know our graph is going to go through that point 0, 0. There it is. If we plug 1 in, we're going to get 1 squared, which is 1, times 2 is 2. And then again, plug 2 in, 2 squared is 4, times 2 is 8. All right, so we're going to go ahead and plot these points. So -1, 2. And then -2, let's see, 2, 3, 4, 5, 6, 7, 8, right there. Right, then we're going to have 1, +2, and then +2, +8. And then we're just going to draw our parabola through those points. right? Technically, you should have your little arrows on the end there, right? And our axis of symmetry for all of these graphs is going to be, because our vertex is at 0, 0, our axis of symmetry is going to be x equals 0, okay? If you note, that graph gets a little skinnier than this graph up here, because if you think about what you put in front of your x squared is sort of like changing the slope in a way, if you think back to our linear graphs. So if you add 2 in front versus what is understood to be there as a 1, you're going to increase on both sides of this graph at a greater rate. All right, so let's take a look at this guy here. We have y equals negative 3x squared. Again, our vertex is going to be at 0, 0. But take a look at our a value this time. Our a value is a negative number. So our parabola is going to open down. It's going to look like that. All right, so we're going to go with our same x values that we did in the last example. So negative 2, negative 1, 0, 1, and 2. All right, so if we plug negative 2 in here, okay, negative 2 squared gives us 4. 4 times negative 3 is negative 12. Okay, plug negative 1 in. Negative 1 squared is positive 1. Positive 1 times negative 3 is negative 3. Again, this is our vertex, so it's 0.00. If we plug a positive 1 in, right, 1 squared is 1, so we get negative 3. And if we plug a positive 2 in, again, we're going to get a negative 12. So if you kind of take a look at the pattern here, right, whether you plug in a negative or a positive number in for x, you're still going to get those same y values. And that's why we end up getting that mirror symmetrical shape of a graph. So let's go ahead and plot our points. So we get negative 1, negative 3. Positive 1, negative 3, and then negative 2, negative 12. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's going to be all the way down there. And then positive 2, negative 12. So if you notice, when we add a 3 in front, even though it's a negative, right, we get an even skinnier parabola. So you notice the higher that coefficient gets, sort of the steeper those sides of the parabola go, or the skinnier overall that parabola gets. And that's called a shrink, because it's shrinking toward the y-axis. All right, so let's see what happens when we add a fraction, right? So this time our a value is 1/3, and it's a positive number, so we're going to have that U shape that opens up. And again, we're going to do our x and y values. The math will be a little trickier because we're working with fractions this time, but it shouldn't be too hard. So we'll go with a negative 2, negative 1, 0, 1, 2. And again, our graph is going to open up. And we're going to have a vertex, which this time will be our minimum point at 0.00. So I'm going to just go ahead, fill that 0 in for right now. So if we plug a negative 2 in for x, negative 2 squared is 4. 4 times 1/3 is 4/3. Plug a 1 in, negative 1 squared is 1 times 1/3, we get 1/3. Right, and again, we know that even if we plug these positive numbers in, we're going to get the same that we got when we plugged the same negative values in. Right, and that's what creates that mirror image. So let's go ahead and plot our points. So negative 1 and then 1/3. It's going to be right about there. And then negative 2 and 4/3. So 4/3 is about 1 1/3. So we can go ahead and plot that right about there. It's not perfect, but it's enough to get us our parabola. And if you notice, when we add a fraction as our coefficient, we get a wider looking parabola than we did with our parent function. Okay, so when that a value is less than 1, meaning it's a fraction or a decimal, you will get a stretch, a wider parabola than you would just with the parent function. All right, so last example, and then I'm going to have you guys do some of your own. We have an a value for this function of a -1/2. Okay, so that's a negative value, meaning our parabola will open down. And let's find our x and y values and plot our points. All right, so we'll go with -2, -1, 0, 1, 2. Right, our vertex is at 0.00. If we plug a -2 in, -2 squared is 4. 4 times 1/2 is 2. So that's a y value of -2. -1 squared is 1. 1 times -1/2 is -1/2. Right? And then we can go ahead and bring those same y values down with our positive x values because we know we're going to have a mirror image. All right, let's plot our points. So we have -1, -1/2, so right there, and then -2, comma, -2. Plot those mirror image points and draw our parabola. Okay, so that is graphing quadratics in a nutshell. Again, these are only quadratics where we have an a value, so a coefficient of that x squared. And now I am going to trust that you can try some of these examples on your own. So thanks a lot.